So Friday, we took a kind of a detour into what real scientists do and how real science is published, which is peer-reviewed scientific journals. And then you read one, for better or for worse. But that was four pseudoscience red flags to set your BS detectors a beeping. There's one more. We're going to spend all of today on it because it's that important. Couple things first. Do you know what that graph means? Every graph tells a story. What story does that graph tell? Interesting. So what this graph actually says is that as the number of times a book is banned increases, so do the number of kids who want to read it. Immediately, she turned that into kids only want to read stuff because it's banned. And that's the conclusion most people would draw from that graph, I would say. That graph represents what is called a, well, do you know? Do you know the C word? A positive what? Correlation. Good. Correlation. That's a positive correlation. Here's another one. I collected that data myself. And so, of course, that tells me right there, that data, that correlation between test days and bathroom visits tells me that my tests make people sick. And so the increased number of bathroom visits is due to my tests making my students ill. What do you think it is? Because it's real. I can tell you, absolutely, every year, way more on test days than non-test days. What do you think, Selene? So they, I don't let them go in the middle of the test, but like, you think they get so just like caught up and stressed out in the test, they're like, I need to walk in a breath of, well, not fresh air, but yeah, that could be it. Any other ideas?
Study or cheating.
Maybe they're going to text their buddy the answer to the hardest question on my test. Yeah. Anything else? Yeah, maybe the nervousness has triggered certain natural processes, and they just got to go to the bathroom now, and it's nerves that does that to them. Yeah, good. So what you're doing is basically, I proposed a causal relationship, right, for this correlation, and you're giving me alternatives to it. That is going to be the main idea of today. So this graph, this positive correlation, which says that basically the wealthier the family, the more likely they are to have drowning deaths in that family. And I'm going to tell you that that is obviously because rich kids can't swim. Because, you know, they've been coddled and pampered their whole lives. Nobody made them learn how to swim, that basic survival tactic. And so, yeah, they get in the water and they sink like stones and they can't swim. Give me a much more likely explanation. Eli.
Well, if people have pools in their backyard, which means that they can drown in the pool.
You're saying that to have a pool in your backyard, first of all, requires wealth, yeah? And second of all, increases that family's risk of having a drowning death. I like it. Someone take it further.
It's much cheaper to go like inland in the U.S. than to go to like the beaches. So they're visiting like Cozumel, Mexico, and Florida.
Yeah, because this is Ohio families, right? Ohio is very much landlocked if you don't count all the fake lakes that we create by damming up rivers, and if you don't count the one Great Lake up north. That's it. That's all we've got. Access to water in general, whether it's a pool or, like you say, a fancy vacation to Cozumel, or even the East Coast or West Coast of the United States, costs money. So access to recreational water certainly correlates with money and correlates with drowning deaths So I proposed that A caused B, and you gave me a C, right? There's a C that's causing both A and B, wealth, right? Wealth is the thing that draws these two things together. Does that make sense? You got it? So this is this kind of classic, the pirates will make sense in a minute, classic example of using correlation to imply causation. And usually, this is the part where you start writing. Usually what we find is that this is done, the mistake is made most often with observational studies. Observational studies are what you do when you can't do a real experiment. For example, if you want to prove that tobacco use causes cancer, are you allowed to pick 200 college kids at random and force half of them to smoke a pack a day of cigarettes and half of them not to? Nope, not allowed, right? You're not allowed to do that with anything that might cause harm. So what do you do instead? You find people who have already made the choice to smoke and people who have already made the choice not to, and you take data from them. That is a huge bummer, science-wise, right? Letting people choose what group they're in screws things up royally. Often we call these observational studies, where we study things that have already happened, choices people have already made. Uncontrolled experiments is another name for them, because they're not, right? You didn't get to select your groups. You didn't get to do the double blind thing. Not that observational studies can't tell you stuff. Observational studies for sure can tell you all kinds of correlations. It was known from early on that there was a strong correlation between tobacco use and cancer, among others. The problem was, since you can only use observational studies, it's really hard to prove that causative relationship. Why doesn't that correlation automatically mean that smoking causes cancer? Give me an alternative explanation, like you did with the drowning dance. Play big tobacco company for me. What did they say? Okay, but there's a strong correlation. It's not a coincidence. It is truly a correlation. But could there be other reasons for that correlation than the smoking causing the cancer? What do you think? What do you mean?
Drinking a lot of alcohol on a daily basis.
The amount of cigarettes smoked.
I mean, you're telling me things, but not telling me why they're linked to the smoking.
Smoking more cigarettes might lead to a higher risk of cancer.
That's what I was trying to say, is that the cigarettes caused a higher risk of cancer. But tobacco said this. They said, well, what if choosing to smoke just means you're also likely to choose other high risk behaviors, like drinking alcohol, maybe. Like, I don't know, driving cars fast. No, that doesn't cause cancer. Like other unsafe behaviors, and that's what's causing the cancer. It's just that they also made the choice to smoke. It's really hard to prove causation. Here's a weird example, not as weird as the pirates. Have you seen this statistic? 80% of accidents occur within 10 miles of the home. What are they trying to get you to do when they tell you that statistic? 80% of accidents occur within 10 miles of the home. So drive safe and wear your seatbelt. Exactly. And the implication here is that correlation, that so many accidents occur within 10 miles of your home, means that it's because people are careless. People are driving like braille driving. They're driving like because they know this route cold, right? They've done this a million times. They're just going to the grocery store, so they're texting and they're distracted, and boom, they hit a parked car, right? Because you're less careful when you're close to home because you think you know everything. That is not what that statistic tells us.
Also, people are more like, when you go somewhere, you're most likely to stay somewhere inside of 10 miles. So.
You got it immediately. What you need to know is, well, what percent of total driving happens within 10 miles of the home? You know what the average is? It's like 90. So if 90% of your driving happens 10 miles from your house, only 80% of accidents happen there, it means you're actually slightly safer. It doesn't mean what you think it means, right? All right, here's the weird example. Steadily, over the last 100 years, the number of pirates on this planet has decreased. Also, the average global temperature has increased. Therefore, obviously, global warming is caused by a lack of pirates. I even have a graph. Must be true, right? I have a graph. And it goes even deeper. Check this out. Somalia is the country with the highest number of pirates and the lowest carbon emissions of any country. Look at that correlation. Now, that's one where I bet you can find the C. The factor that influences both carbon emissions and piracy. Ooh, developedness. That's a code word. Now, what does it really mean? What does she mean when she says developed? Well, it goes with it. Well, that's it. Straight up wealth, right? It's one of the poorest countries on earth. So what does it have to do with carbon emissions, though?
They don't have access to stuff that releases.
There's just not as much carbon releasing stuff. Combustion engines cost money, right? Factories go with domestic wealth. So yeah, there's less carbon emissions because they're a less wealthy country. And of course, piracy is something people will turn to more if they're poor. So there you go. They also happen to be sitting on a pretty fat shipping lane. But yeah, there's a C there that's influencing A and B. It's not A causing B. I know that's a silly example that kind of doesn't make sense, but it's an attention battle. So basically, now we get to talk about storks. Weirder and weirder. What I'm going to do with this worksheet is I am going to give you two true real-life correlations, and your job is going to be to give me plausible alternatives to the ridiculous positive relationship that I suggest. Correlation number one, and it is real, this is real data, is that in Europe, it turns out that the number of storks, and storks are a long-legged wading bird that hang out in the water. That's a stork. The number of storks strongly correlates with the average birth rate of humans. Storks correlate with birth rate. Therefore, obviously, storks bring babies. That's the causative relationship I'm suggesting. Now, there's 3 questions that go with this graph. Letter A, is the causal relationship between A and B biologically plausible? I think you'll probably figure that out pretty quick. If the answer is yes, then how important do you think that relationship is? For example, is A the only cause of changes in B? Fine. Those 2 should be easy. It's letter C you want to put your effort into. Letter C says, what are 2 plausible alternative explanations other than coincidence? Okay, you can't just say it's a coincidence for the correlation. So you need to come up, the correlation's real. It is true that the more stork breeding pairs there are, the higher the human birth rate is in Europe. The question is, why? What is the real reason for that real correlation if it's not the stork string babies? So that's where you want to put your effort. I love this activity because I love the weird ideas you come up with. Some of them are hilarious. The second graph is maybe a little more plausible. It says that in the US, calorie content of dessert recipes printed in a city's newspaper correlate with the obesity rates in that city. In other words, the higher calorie the dessert recipes in the city's newspaper are, the more obese, overweight that city's people are. Therefore, obviously, the dessert recipes are causing people to be fat. This one's hard for you. It's hard because you're going to come up with a bunch of ways of saying that I'm right. When in fact, when you get to letter C, your job is to give me different reasons other than the correlation I suggest. If it's not that the recipes are causing people to be overweight, what's another explanation? 2 others, in fact. Okay? I'm going to let you work. Oh, good. Like almost 20 minutes. So please put some effort into this. First thing tomorrow, I'm going to make you tell me what you came up with. So make sure they're good. Ask questions if you got them.